In today's note, we are going to continue with probability and look at tree diagrams. So tree diagrams, what they do is that they display all the possible outcomes of an event. And each branch of a tree diagram, I'm going to highlight each branch, because that is a key thing. Each branch in a tree diagram represents a possible outcome. Just highlight that whole sentence. So each branch represents a possible outcome, and tree diagrams can be used to find the number of possible outcomes and calculate the probability of possible outcomes. So the key thing here is that it's the entire branch is considered one outcome. So if I'm looking at this example where I am flipping a coin twice, I'm looking at what are my possible outcomes. So an entire outcome is something that goes like this. So that is considered one branch right there that I highlighted. It's not each individual one, it's the entire pathway or entire branch that's considered one outcome. So if I were to look through the situation, I'd have 1, 2, 3, 4 different outcomes in total. You could also count just the last row. 1, 2, 3, 4. We have 4 outcomes. You could also go through and count the different pathways if you wanted to as well. So that is a tree diagram. We can also use that to help us with probability, because we can then see if I'm flipping a coin twice, we can see how many different outcomes there are. So if I wanted to know what is the probability of getting 2 heads, well, that outcome I can see occurs once out of 4. So there is a 1/4 chance, or 25% chance. So basically it just allows you to visualize the situation. So for example, when buying a car, you have the following options: cloth or leather seats, 2-door or 4-door, and red, black, white, or silver paint. We want to create a tree diagram to figure out or to illustrate the number of choices we have when buying the car. So then we can then figure out how many different choices, or in other words, how many different combinations do we have. So basically you're going to start off at the top. And we're going to start our branch. So our first 2 options, or you could think of your first decision, that is going to be, and I'll highlight it, the cloth or leather seats. So that means I have either cloth or leather. That is my first decision that I have to make. Depending on what I make from there, I have 2 choices off of that. And that is the next one, the 2-door or the 4-door. So from there, I have some more options. So I have a 2-door in both scenarios, or there's the 4-door, again in both scenarios. And then the final decision, so that was decision 2. The other one was decision 1. And finally, the third decision we have to make is going to be the type of paint, or the color. So from there, under each door, I have 4 options. And those options are, you have either red, black, white, or silver. And this basically is the same thing for each type of door. So you have the red, the black, the white, and the silver. Over here, same thing. The red, the black, the white, silver. And finally, again, red, black, white, silver. So those are all our possible combinations or possible choices that we have. Remember, each branch or pathway is considered an option. It's not just each spot, it's the entire pathway. So again, I'll highlight one. So this would be one pathway. Cloth, two-door, red paint. Right, so how many possible choices in total do we have? Well, you could go through and highlight each individual pathway or count each individual pathway. An easy thing to do is you can just count the bottom. So there's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So in total, there would be 16 possibilities. So 16 possibilities or 16 possible choices for choosing a car in this scenario. And that's how we use the tree diagram. The next question or example, you have a 3-question true or false quiz and have no idea what is going on in class. If you completely guess on each question, and the first part of this is create a tree diagram of the possible combination of guesses you can make. So if we have no idea what we're doing, we're just going to randomly guess what are the possible guesses that we can make. We're going to do our tree diagram slightly different, and again, it's still going to be the same thing, just laid out in a different fashion. So in our first question of the true and false, right, because again, there's 3 questions that are true and false, so we're going to have to do this split 3 times. So our options are either true or false. Off of each question, we move to the next one, and again, there's the 2 options, true or false. So this is our question 1, this is our question 2, and then again we move on to that 3rd question where there is again 2 options, true or false, true or false, true or false, true or false. So those are all of our possibilities. So therefore, there are, and we can see there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possibilities or possible combinations. Again, we're looking only at the entire pathway as an option. So again, there is one pathway as an option. So just to show you again what it looks like. So there are 8 possible combinations or possible choices you could come up with if you're just randomly guessing on 3 true and false questions. So B, now we're going to use this tree diagram to help us come up with the possibility or the probability of something happening. So the first example, guessing false 3 times. So what is that, the possibility of that happening? And if I look at my table, I'm going to get rid of that one pathway. If I'm basically going to go through and follow it. So my first choice, I have to choose false. Second choice, I'm choosing false again. Third choice, I'm choosing false again. There is only one pathway that has 3 Fs or 3 falses. So the probability of choosing 3 falses or guessing false 3 times is equal to only 1 successful outcome over 8 possible outcomes, or 8 total possible outcomes. For number 2, guessing 2 trues and 1 false. So the probability for 2 trues plus 1 false, I have to go through and look at how many times that occurs. So if I go through and look, well, the easy one, just kind of follow your pathway. So true, true, false. Then you can also have true, false, true. So still 2 trues. false, true, true. And those are the only 3 options that we have. So there are 3 pathways that give us 2 truths and 1 false. So that means, our probability or the possibility of this happening is going to be 3 over 8. I guess I'll write it at the side. So we have true, true, false, true, false, true, false, true, true. And the other one, it was only F, F, F. So let me just get rid of these branches. And in our next example, or next question, passing the test if all the answers are true. So if all the answers are true, we need to at least get two trues. Because if we get 2 trues, that means we got 2 out of 3 questions, or 2 out of 3 marks, which would mean we would pass. So now we have to go back and look and see, okay, how many pathways are there where we get at least 2 trues? So if we go back and look, well, the first one, so 3 trues is still good because that still counts, because we have at least 2. Then true, true, false, true, false, true, false, true, true. So again, those are our only options. I'll write them down. So true, 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 false, true, false, true, and false, true, true. So those are our possibilities. So there's 4 pathways that give at least 2 truths. So the probability of passing is 4 out of 8, or 1/2, or you could think of 50%. And again, I'll go back and remove these. But again, that's the general idea of how you can use the tree diagram to help you figure out the probability, because now we get to see these pathways. For example 3, suppose a couple would like to have 3 kids. Determine how many possibilities there are. So if we're going to look at whether it's a boy or a girl, we're just going to keep it to the 2 right now, just make it a little bit simpler to count or to do the possibilities or probabilities of. So the first child, a girl or a boy. So we'll say that's child 1. Child 2, again, same idea. Girl, boy, girl, boy. And the third, again, same type of pathway. Girl, boy, girl, boy, girl, boy, girl, boy. So how many pathways are there? If we count again we can count each pathway, or we can go through and count all the n numbers. Either way, therefore, there are 8 possibilities. B, determine the theoretical probability of at least 1 girl. So, probability of at least 1 girl. So if you go through and you count all of them, again, we know the total has to be 8. And if we count each pathway for how many times there's at least 1 girl, we can go through and we should see that there are 7 possibilities where there's at least 1 girl. You could also do the opposite. How many possibilities are there with no girls? And again, that's only 1. So all the remaining would have to be at least 1. But we can go through and write out all the possibilities. So 3 girls, girl first and 2 boys, girl, boy, girl, 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 boy, boy, girl, girl, boy, girl, boy, 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 girl. So those are all the different possibilities. Determine the theoretical probability, C, determine the theoretical probability of having 3 girls. So again, there's going to be 8 total possibilities, and there's only one scenario where we can have at least 3 girls, which is just girl, 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 because there's only 3 kids, so that's the only possibility where we could have 3. And finally, suppose the couple wants to have a boy first and a girl second. What is the likelihood or probability of that happening? So the probability of boy first, girl second. Again, we know the total is going to be 8. So how many scenarios are there when we have a boy first and a girl second? And if we look at this, we can see that it is either a boy, girl, girl, or a boy, girl, boy. Those are our only 2 possibilities where we have a boy first and then a girl second. So there's 2 out of 8, or 1 over 4 probability of this scenario happening. So again, the main thing from this is just tree diagrams, how we can use them to represent different images or different scenarios to help us visualize the possibilities, which we can then use to come up with theoretical probabilities.